Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Dear students, this is our next problem, and this problem has also been chosen from the book Modern Physics by Kenneth S. Crane. Okay, so as usual, first we come to our statement. Okay, electrons are accelerated to high speeds by a two-stage machine. The first stage accelerates the electrons from rest. Okay, here from rest is important. Okay, the first stage accelerates the electrons from rest to V equal to 0.99 c. Okay, where c is speed of light. Okay, dear students, this V is actually equal to 0.990 c. Okay, or 0.9900 c or 0.9900000 c. Okay, the second stage accelerates the electrons from 0.990000 c to 0.999000 c, where c is the speed of light. Okay, part A, how much energy does the first stage add to the electrons? Part B, how much energy does the second stage add in increasing the velocity by only 0.9%? Okay, dear students, in this problem I think there is nothing new. Okay, all tools are those which we have used or utilized in our previous problems. Okay, so I think it is quite simple, but this simplicity will appear when we will go to solve this problem. Okay, so in the next step we move towards helping tools. Okay, helping tools. Tool number 1, total energy of a particle. This tool has many times been analyzed in previous modules. Okay, anyhow, just as a formality, I once again read this tool. Okay, total energy of a particle, that is E, is equal to kinetic energy K plus rest energy mc square, and this expression alternatively becomes equal to mc square divided by 1 minus v square over c square, where v is the speed of particle. Okay, and c is the speed of light in vacuum. Okay, this factor, that is 1 over 1 minus v square over c square, is also sometimes denoted by gamma. That is, gamma is equal to 1 over under root 1 minus v square over c square, and this gamma is called Lorentz factor relating first frame of particle and frame of observer. Tool number 2, this tool has also been shown many times in previous problems. Okay, in this problem we will use the value of mc square in terms of million electron volt. Okay, that is, in case of because here electron is under consideration, so we will use the value 0.511 million electron volt or 511000 electron volt. Okay, now we come toward its solution. Okay, only two tools are quite sufficient for our requirements. Okay, solution: let E0, E1 and E2 be the rest first accelerated and second accelerated energies of the electrons. Okay, that is E0 rest energy E1 first accelerated energy and E2 second accelerated energy. Okay, this implies that E naught equal to mc square equal to 0.511 million electron volt. This value has been taken from tool number 2. Okay, tool number 2 has been used in several problems in our previous videos. Okay, now we come towards solution of part A. Okay, part A. In part A, we will find E1. Okay, E1 is equal to mc square over 1 minus V1 square over C square. Here mc square is the same, that is as per tool number 2, that is 0.511 million electron volt or 511000 electron volt over 1 minus, dear students, V1. What is V1? V1 is the first given speed. Okay, first is 0.99 and second is 0.999. Okay, so here in place of V1 we will use 0.99 C divided by C square. Here C square will be cancelled out with C square, and in the next step we will be left with E1 equal to 0.511 million electron volt over 1 minus 0.98. What is this 0.98? This is actually square of 0.99 is 0.98. Okay, quite small difference. That is to say, what I have said that if we multiply 0.99 with another 0.99, then we will get the result 0.98. Okay, and then we will subtract this value from 1, then we will, I hope, get 0.02, I think. And when we will take under root of this resultant value, this under root will become equal to 0.141. Okay, in the next step we will divide 0.511 with the under root value of 1 minus 0.98, which is 0.141, and hence E1 becomes equal to 3.62 million electron volt. This implies that change in energy equal to delta E. Dear students, delta is always used to denote change. Okay, here change is in between E1 and E0. In the next part, change will be in between E2 and E1. Okay, in this next part we will find change in an energy, that is equal to delta E equal to E2 minus E1. But here in this part we are dealing with E0 and E1, and hence delta E is equal to E1 minus E0. Value of E1 we have calculated in the above line, that is 3.62 million electron volt, and E0 is given in the tool number 2. Okay, so both values are in million electron volt, and hence their difference will become 3.109 million electron volt. Okay, hence change in energy, that is delta E equal to E1 minus E0, becomes equal to 3.109 million electron volt. Now we move to part B. In this part we are going to calculate the value of E2, that is value of second accelerated energy. Okay, for the purpose of calculating second accelerated energy, mc square will remain the same. However, in the Lorentz factor, in place of V1 we will take value V2. We know that V1 was equal to 0.99, that is 0.990000, but here value V2 is equal to 0.999. Okay, that is out of 1999 parts. Okay, so as in the previous part, c square will be cancelled out with c square. Moreover, if we multiply 0.999 with another 0.999, then we will get the result 0.998. And when we will subtract this value from 1, then the value which we will get, we will have to take under root of that value, okay, and then under root of that value will become equal to 0.0447, okay. Hence in the next step we will divide 0.0447 by 0.511, and hence we will get E2 equal to 11.43 million electron volt. This implies that change in energy equal to delta E is equal to E2 minus E1 is equal to 11.43 million electron volt minus 3.109 million electron volt. Okay, in part A we have calculated E1, which was equal to 3.109 million electron volt, and difference of these two values, that is E2 minus E1, becomes equal to 8.321 million electron volt. Okay. Delta E, that is change in energy, that is equal to E2 minus E1, has become equal to 8.321 million electron volt. Now, if we divide 8.321 million electron volt by 3.109 million electron volt, then we will get the factor 2.68. Quite obvious, okay. Then this implies, okay, this result will imply that second stage adds about 2.68 times as much energy as first stage, okay. So what is the nutshell of our solution? Second accelerated stage is 2.68 times greater than first accelerated state of energy, okay. This is times, that is, if we multiply first accelerated energy with 2.68, then we will get second energy state, okay. And this is the end of this problem, this video. Till next video, Allah Hafiz.